Hey, welcome back to my channel, guys, and hope you learn a lot about math method. For these short videos, we're gonna cover for 5E and maybe 5F. Let's see how it goes. Okay, let's do it together. So 5E is graphing logarithm functions. Again, before we say logarithms, you should be familiar with the exponential functions because logarithm and exponential functions, if they have the same base, so they are inverse function to each other, as emphasized in the left-hand side graph over here, right? And again, for our logarithms, you also distinguish between the base. Okay, different base, of course, different graph, but if base is greater than 1, then it's going to be increase like this guy. And if the base is from 0 to a and to 1, it's going to be like this. Okay, once we know the basic graph, we can start to join the logarithm functions or logarithm graphs. Over here, if suddenly the question asks you to draw some number times logarithm, again, for this, if we're using the hand sketching from exam 1, it's pretty hard for us, to show the dilation factors. What we can do is just label some point, maybe as this guy, to show, you actually consider the dilation factors, and then just make sure you include your x-intercept or y-intercept if possible, or like the isotopes if possible. Okay, this one is pretty straightforward, and for the next one or for next two is a bit tricky. First, we always can find where the isotope is. Remember, for our exponential functions, our isotope is x equals 0, and the y equals 0 is just like horizontal lines. But for our logarithm, since they are inverse function, so there will be x equals something. And as we know that the logarithm functions, the domain always should be greater than 0, right? So which means x minus 5 should be greater than 0, so x greater than 5, which means x equals 5 is the asymptote. So we just draw this one first. Okay, x equals 5. Then we see, okay, this one is greater than 1, the base, so it must look like this, okay? And for the rest, it's pretty straightforward. We just find the intercept, and you actually don't need to find the 72061. But if you find, of course, it's going to help you to drawing the graph more smoothly and more accurately. But for our final year exam, we just require some intercepts and asymptotes. But just make sure you're not drawing like straight line to connect them. Use a smooth curve, okay? For B, again, the same thing. We draw asymptotes, okay, which is x equals -4 over here. And then if we ignore the negative sign first, we just draw the log 3 x plus 4, then it's actually gonna looks like this. Makes sense? If we ignore the negative sign, right? But once we include the negative sign, we need to do the reflection. Sometimes you're going to say, so I'm not sure, reflect in y or reflect in x or reflect in what. Okay, I give you some ideas. Because this negative sign is in front of everything, so we know y equals x squared, right? It's going to look like this. And if we adding a negative sign in front of everything, it's of course easy. It's going to look like this. So which means the reflection is reflected in the x-axis, as they said over here. Sorry, reflection in the x-axis. So which helps you to define and help you to sketch. So we always use special example or special case to help us to simplify our problems or equations. But of course, if you are really familiar with the chapter 3 transformations, you can get this one pretty easy and straightforward. Okay, let's just keep doing. For next one, again, they involve with like translations, dilations, but not the reflections. So find the asymptote, then find the intercept, then draw the graph. That's the way we do the logarithm graph. Okay. But from here, for this page 231, these two equations, okay, is not required. Not required, by not required, I mean in the final year exam, I never see this type of problem. Or after we change the syllabus, so I mean since from 2016. But uh, I said I suggest or highly recommend you still copy these two formulas down on your reference book, or we call bond reference, so you still can bring it. So sometimes you might use this one to help you to, I mean, to solve problems, especially for this guy, change base. Okay, this is really important in China, but it's not that highlighted over here, but it's still worth to know. And another thing is this one is even harder, but to be honest, we not really use for this one. It's really annoying because if you want to change the base, I mean, from 2 to the power of x, suddenly change to the graph e to the power of x, then you have to use this guy. The following example is introduced over here. And for this type of problem, I never see it during the final exam, but if you get SAC, your teacher might ask you for this one, to distinguish you guys with full marks and like 90 plus, I don't know. So make sure you read this one and get these ideas about these two formulas, okay? That's for 5E, and for 5F, I just want to quickly go through because I mean, if our 5E is forward way, then 5F is backward way. So 5E is from equations to graph. Now we want to from graph to equation. So essentially they are the same thing. And again, for this type of problem, the strategy is the same. We just like substitute numbers in and solve simultaneous equations. Okay, and we use example 21 to illustrate my point. So first we have y equal a to the power of ex, e to the x plus b, and we got 2 points, which are 0, 6 and 3, 22. So we plug in to get two equations over here, and we just manipulate these two things to get our a value and b value. Okay, and for 22, exactly the same, but uh, this one is just like log instead of exponential functions. Okay, I will ask you guys to check by yourselves. And for the example 23, the number of a and b, especially for b, is going to be a little bit weird with logarithm. But again, log e 4 on 3 is just like number. Okay, but we don't know how much or what's the exact value. We use cat, we only gave you the roundings, but again, it's just a number. So you find it already, like what we hold over here. But just emphasize one point in our case or later on in your uni life, uh, for ln, ln, it's just like shortcut way for log e. Okay, ln is a shortcut way for le, and lg, which means like this guy, lg is a shortcut way for log 10. Okay, and also if in your case you look at some like 2 to the power of e to the 0, 6, it means 2 times 10 to the power of 6. Okay, just some notes for you guys to uh, refer. Okay, so for 5F, I highly recommend it you guys try 3, 4, 6, and 8. Okay, of course you can also try the 9, 10, 11, 12 to get these ideas how to calculate A and B. And since we still have a little bit time, we can still do one more question together. For this, let's say for 8, sometimes you can see, sir, this one just give me 1 point. Okay, how suppose I do that, right? We have two unknowns, A and B. And but actually they give us a really nice hint here. They give us one asymptote, which is x equal 5. And let's just picture the graph of logarithm, and with asymptotes, our logarithm inside it means just 0, right? Because it's always greater than 0. So in this case, they tells us b is 5. Make sense? B is 5, then x minus 5 greater than 0, then I got x greater than 5, which the graph is gonna look like this. So once I got b equal 5, I plug in 7 and 3 in. 3 equals a to the power of log 2 x minus 5. Then I can just solve for a. Okay? Sorry, it's 7 minus 5. My bad. So it's just like 3 equals to a times log 2, 2. Log 2, 2 just like 1. So a is 3. Right? So the final answer is just y equals 3 times log 2. Then brackets x minus 5. Hopefully the 5e and the f help you guys to even familiar, closer to be the master level of the logarithm functions. For our next video, we're gonna cover the solutions for exponential equations using logarithms. So basically calculates by hand, and sometimes we're gonna use CAS to help you a little bit. And if you think my video is helpful, please click the like button and subscribe my channel. And I see you guys for the next video. Thanks guys. Bye bye.